Okay, this video is about atrial fibrillation and leaky gut. I'm going to have another lecture separate from this that's going to explain other mechanisms of atrial fibrillation. And the reason why this is useful is tons of people have Afib, and most of them don't know why. And once you understand the reasons, a lot of these reasons are preventable, so you can prevent them. Leaky gut's easy to prevent. Okay, so here's a drawing of leaky gut that I made a while ago showing that when you get leaky gut, you get bacterial endotoxins passing into the blood. From gram-negative bacteria, you get LPS, lipopolysaccharide. From gram-positive bacteria, you get LTA, lipoteichoic acid. These will cause a deformity of your blood clotting protein. Your blood clotting protein, fibrinogen, is normally shaped like a slinky or an alpha helix. It's called secondary protein structure, and it's alpha helix configuration. It's hard to stack a bunch of alpha helices. They're kind of like soda pop cans laid on their side. They don't stack well. You can't stick them together very well. On the other hand, after interacting with LPS or LTA, also with free iron, if you're iron overloaded, you have high free iron, that can undergo ferrous redox cycling, Fe2 plus, Fe3 plus, give off electrons, generate free radical reactions like the Fenton reaction. Okay, anyways, that'll change the shape from alpha helix being cylindrical to being flat like a beta pleated sheet. And then the beta pleated sheets will stack up on each other and they'll form hydrogen bonds in between them. So they will form a stack like a stack of playing cards. And then because they're bound together, the molecule's molecular weight is increased. The bigger the molecular weight of a molecule in aqueous solution, like blood plasma, the more likely it is to precipitate. To precipitate is to clot. So this makes the blood clot, and these are bad clots. A normal clot is kind of linear, like spaghetti. But when you have these clots, they're all mangled, and they're called dense matted deposit. So you have to understand that concept of amyloid transformation, meaning to go from alpha helix to beta pleated sheet, to subsequently aggregate, stick together, and to clot. Okay, that's the mechanism. That's amyloid clotting. They'll also call it, because it's from fibrinogen, and it's a deformity of the fibrinogen, an amyloid deformity of the fibrinogen. They'll call it fibrinoid clotting. And they start out being very small, these clots, so they call them microclots. This is all the terminology you need here because you're going to hear this a ton. If you're serious about understanding atrial fibrillation, if you're serious about understanding things like dementia, thrombosis, clotting, and all that, you have to know this. Otherwise, you're an ignoramus. Okay. All right, so here's the papers, and the two who've done the most work on this subject are Douglas Kell and Etheresia Pretorius. He's a PhD from England. She's a PhD from South Africa. I've done previous lectures on them. I've done previous lectures on amyloid clotting, all of this stuff. But today I'm just specifically talking about it in the context of atrial fibrillation. So they wrote this paper here in 2024 talking about how this is associated with atrial fibrillation. And you can also get it from viral proteins. So we talked in particular about LPS, LTA being bacterial proteins, but viral proteins can do this as well. Okay, and also I talked about iron overload. She says if you just expose the blood to iron, you'll form these dense matted deposits. See, these are not like spaghetti. These are more of a big irregular mess, and they're called dense matted deposit. The reason that's significant is the nice linear clots that are like pieces of spaghetti, they're easily to lyse. Blood can form these clots and dissolve them very quickly, turn it on and off. But these dense matted deposits are harder to dissolve, to lyse. And what that means is they can plug up small arteries in your heart and make local cardiac muscle cells hypoxic, and that can damage the mitochondria of these cells, and they can become dysfunctional. That can cause rhythm abnormalities, energy crisis problems with these cardiac atrial cardiomyocytes. Okay, so this is a key point to get. Leaky gut, amyloid clotting, iron overload, amyloid clotting, subsequent atrial fibrillation. So how do you prevent it? Avoid all the things that cause leaky gut. I gave separate lectures about that. Avoid being iron overloaded. Avoid eating meat. Get your iron levels down. Get your blood ferritin down to, ideally 30 to 80. Like mine was up around 300, and I just pull off a couple tubes every time I go for a blood lab, and now I've got it down to about 110. My eventual goal is to get it down to 80. Okay, so anyways, here's a red blood cell, and here's the irregular dense matted deposits. Here's a drawing from the paper by Douglas Kell and Etheresia Pretorius from 2024. And this is showing a normal fibrin clot where, again, it's like pieces of spaghetti laid over each other, very easily removed by fibrinolysis, okay? But when you get these beta pleated sheets, they stack up to cause these giant molecules that then have an irregular shape when looked at with electron microscope, and that's called amyloid clotting or fibrinoid clotting. And these are more stable than the normal spaghetti-like clots, and they can plug up small arteries in the heart, and they can cause atrial fibrillation. So that is leaky gut leading to amyloid clotting as a mechanism of atrial fibrillation, and you prevent this by avoiding leaky gut and also by avoiding being iron overloaded.